Welcome to the DSL podcast. I am Dave Cole, your host, and today we have an interesting topic. We're going to be talking primarily about AI reliability. If you're wondering what AI reliability is, then you've come to the right place. Our guest today is Celeste Fralick. She is currently the Chief Data Scientist at McAfee. She hails from North Texas. Originally growing up in Alaska, that's quite the latitudinal change there, Celeste. She also has her PhD from Arizona State in biomedical engineering. And interestingly enough, her dissertation was a statistical clinical decision support tool for determining thresholds in remote monitoring using predictive analytics. So when I saw that dissertation, Celeste, I immediately thought that must be the source of your passion for AI reliability. So talk to us a little bit about what is AI reliability?
Well, hi, Dave, and thanks for having me on. Oddly enough, that title, the only thing that title doesn't have in it is novel. But the dissertation, which I worked full-time and went to school part-time, really focused on whether grandma was gonna have a COPD episode, chronic obstructive pulmonary disease episode, like she was having coughing and things like that, and could I predict when she would have a COPD episode? And at the end of the day, I could predict within 10 days. So that was pretty cool. So at any rate, so the AI reliability is really about predicting and assessing and predicting your intended function over time in the field. And the one thing that we don't do around AI reliability is have it. We don't have it at all. NIST and National Institute of Standards and Technology in the US and ISO, we've got AI for trustworthiness specs. I think they're really great on identifying trustworthiness, but they have stopped short of AI reliability and measuring reliability in the field.
Right. So when you say functions, I mean, are you talking about trained models that are out there in production,
exactly.
Producing predictions and class? Okay.
Exactly.
And then,
yeah.
And then what are some of those? Just again, dumb it down for your host here. What do you mean by reliability specifically? Like what are you sort of measuring? Is it the accuracy of the model? Help us understand that.
When I think of reliability, which is really the general definition of reliability, is that the probability of a product, a system, or a service will perform its intended function adequately for a specific period of time. And so if I dumb it down, I'd say, don't you want to know how long your model lasts in the field?
Yeah.
Yeah. And, we have model decay, but do we have a mathematical comparison like we do with, say, software or hardware product that we can say my mean time to failure is X for this model? And we don't have that. I can't compare company to company. And so as a customer purchasing a product with a model embedded in it, AI embedded in it, I don't know how long that's going to last. I don't know how long the retraining period is. I don't know about concept drift. I don't know about data decay. I don't know about any of those things. And the NIST and ISO specs do a really great job of describing what things make up reliability, but they don't say reliability. They speak about robustness. They speak about trustworthiness. They speak about resilience. Those three things go in. I believe those three things can go into reliability, and then we can identify those specific items that will drive your model decay. So, yeah.
I was going to say, can you walk us through maybe an example of a model that you've put into production, and like what sort of like processes have you put in place to measure the reliability? I mean, so one thing that's also interesting is you talk not just about monitoring the model to ensure that it is still producing accurate results and accurate predictions, at least compared to how the model performed during training. But you also have discussed being able to predict, as you were talking about, the mean time to decay. So how long that model actually is useful, right? So it's almost like you're building a model on top of the performance of the model.
Right. Exactly. Yeah. In fact, the thing that I recommend is when you have a specific development operations or DevOps arena, and you have an MLOps arena or organization, both of those should have incorporated monitors within those processes to monitor certain items that you do see in the NIST and the ISO specs. The concept drift, the data decay, the data pipeline, and when I speak of, say, data decay, I'm looking at the changes of the data over time. I'm looking at the changes of the labels over time. So if I put those monitors in place, then I know that when those things start to crap out, then I know that my model decay will also start crapping out. And so there's a number of things that you can look at. If you look at model decay going down over time, you can look at a certain number of contributors that a certain number of monitors that can contribute to that decay over time. The best part of all of this is that you can mathematically derive all of this, and you can then predict it to get your mean time to decay, MTDD. So it's a wonderful type of measurement that if you say, yes, I want MTDD, then you've got to go back and say what things. First of all, how am I going to model it? How am I going to measure it? Am I going to do it by model? Am I going to do it by file type? Am I going to do it by family of threats because I'm in security? So you make that decision, and then you go back into your processes of DevOps and MLOps, and you go, okay, what monitors do I have in place? Do I have a monitor of AML, adversarial machine learning, or model hacking? Do I have explainability? Do I have data decay? Do I have the volumes, the skewness, the kurtosis, the variance, those type of things? Do I monitor those, and are they contributing? If I monitor those and they go down or up, how does that impact the model decay? And with that, you can get a mathematical end result. Does that make sense?
Right. It does make sense. Before one thing I do want to clear up for our audience here, you talk about DevOps and MLOps. Can you help me understand like what you mean by that?
Oh, it depends. That's what a good data scientist would always say. It depends on the company you're in. There are many models out there. So DevOps can include the model development, the model training, the model evaluation, the model packaging, the data prep, the data cleaning. Whereas MLOps is taking that model that all the data scientists created, or models, and put that into operations. So you look more along the lines of model governance, model discovery, model security, and certainly you look at monitors in the field like efficacy. So what is in our case, we tend to build a model, embed it in a product, and then in ML ops, we will validate that it works in the product, and then it works in conjunction with other products, and then put it in silent mode to get feedback.
What is silent? What is silent mode?
Silent mode is where we're getting the information, but we're not. Silent mode is we're getting the information, but it's not impacting the customer at all. So it's not live, right?
Right.
So
that's interesting. So you put a model in silent mode, and obviously you're starting to monitor, its prediction, and maybe you haven't, it might take some time to get ground truth. And then, so what are you actually looking for during that silent mode? Are you looking to make sure that, you're measuring its accuracy and things like that, or?
Right. We're measuring all the model, metrics such as the ROC curve, the FP, the false positive, the true positive, the false negative, true negative. We're looking at whether it has any spikes in it or not, whether the trend goes down, whether the trend goes up, and how it compares to the model in the field.
Right. I'm curious, is a lot of who owns the reliability of the model? Is that the MLOps side of the house, or is that the DevOps side of the house, or is it sort of a joint?
It's really joint at this point. We are, because MTDD is a new type of mathematical model, and you can predict. That's what we'd like to do, is to be able to predict MTDD, mean time to decay, and that would help us immensely for resourcing. Right now, our focus is on implementing the monitors throughout DevOps and MLOps, and being very specific about what we want to measure on AI reliability. And the reason I've been driving reliability is because of my background. I started in reliability and quality, and nobody has addressed this. When I do see papers about reliability, it's not about the system. It's about like Microsoft has some really great monitors in place. And they have measuring reliability of software products. They have a great paper out there that speaks to that. But it doesn't speak about the system as a whole. So I think at the end of the day, what we want to do is to have a bellwether measurement like hardware has for many, many years, and compare it from company to company to company, because who wins at the end? We all do, because the customer especially wins, because they have they can now do a comparison of one to one of the companies that offer embedded AI, or however.
That's interesting. Yeah. I mean, I would think that models being, to be able to compare sort of the reliability of a model between companies, it would have to be a fairly standard, type of model. It has to be, sort of predicting the same thing, I would imagine, right?
Right.
Yeah.
Yeah. In hardware, we have FITs, or mean time to failure. FITs is failure in time, 10 to the ninth device hours. So you can actually compare company to company to company. And I could go from one company looking at a particular DRAM and look at that reliability and compare it to another company. In software, we have typically looked at errors detected at each stage. And when you look at the CISQ software requirements, the CISQ is the quality assessment of your software. They speak about resiliency. They speak about stability. They speak about trustworthiness. And it's like, models really don't fit into the software, nor do they really fit into hardware, Right. And so we've got to come up with something. And I'm not saying that I've got all the answers. I think what we've got to do is dream big, start small, and be able to just put something out there and let people throw rocks at it and get better.
Interesting. I mean, do you have any in your at McAfee? I mean, do you have any ideas of what that might look like? I mean, have you gone down that path at all? I mean, certainly you're mentioning mean time to decay for a model, but are there any other sort of reliability metrics that you've tried to put into practice that all your models sort of fit to?
We specifically look at efficacy, how well our model is working for the customer, because at the end of the day, we want our model to work perfect for as long as possible. What I'm looking for is, how do I mathematically predict as long as possible? Right.
That makes a lot of sense.
Yeah. Well, it kind of all came together in reliability. And I started many years ago, about 2 miles west of here at Texas Instruments. And I had some surgery, and I was working. I had just come back from Singapore, and I was doing a really good job, and I was an engineer, right? And the vice president of quality called me. Now, that was about 10 layers up, right? And he called me again. And I'm recovering from surgery at home, so he's got my home phone number, landline then.
Wow.
And I'm going, well, hey, Ron, how are you? And I'm kind of half dragged, and he goes, how would you like to do reliability in Dallas for Texas Instruments? And I went, okay. And, when you're young one of the things that I was always taught from him was, learn as much as you can about the area that you're studying, every portion of it, and then you will continue to, increase your knowledge, increase your stature, and grow in your career. So he was a great mentor.
That's great. Yeah, I mean, I've read some things out there, and some of the things you've said, and you've reiterated that I think a number of times, which is really, don't forget the fundamentals. Like when you're going deep into a particular area, and especially in the world of data science, there's many areas to go into. Don't forget the fundamentals. Is there anything that you do, or any recommendations that you have to stay up on your fundamentals? I mean, I know myself, I have to look things up, and I kick myself when I read it over again. But is there anything that you do to sort of like as a process? I'm
actually the same way. I have had hired 3 women to, not intentionally, but they just happened to be the best for the job. And we ran advanced analytics at McAfee. And we've since dispersed them. And they're all PhDs. And they brought to light state-of-the-art work. And because they're young and hungry, they always sent me the greatest and the latest. The thing that I find interesting is that most data scientists, PhD, masters, whatever, don't have a solid foundation in statistics. And if you're going to monitor to drive to an excellent reliability of your model in the field, you've got to look at things like skewness and kurtosis and mean and distribution and volume of your features and the type of your features. Those type of basics need to be put in at the very beginning, and they're a great start for monitors.
Yeah. Yeah, I mean, one of the challenges in the data science field, as you point out, is you really need to be fairly wide in your expertise. You need to understand, you need to have sort of data expertise. You need to have ideally a statistical background. You obviously need to be able to code. You need to be able to talk to business users and understand the business challenges and translate that into and be able to take that as an input as you build out your model to make sure that it's actually driving business value. So it is not easy, right? To this, and I can just imagine that you will forget things, and you will it's okay, and it's okay to Yeah.
I do response screening for design of experiments on a routine basis, and I look at response screening metrics over and over again. I've done it this year at least twice. Every time I've had to go back to my basics and read it over again. And sadly, I don't think that's because of old age. I think it's because your brain is so full.
Right.
And, when you start looking at things like skewness or kurtosis, you've got to go, what was that again? I know I learned it sometime. Why would it make a difference? And so you forget. There's just too much.
There is.
I like to use the people around me, that are experts in, I'm not a great coder, so I go to somebody, if I have an issue, I go to somebody that has a great coding experience. If we have an expert, I started AML studies at our company about 3 years ago. Adversarial machine learning, but I brought in a lady from Intel that I had known there, and she is taking it much further. And so if I want to keep up on AML, I just go to her and say, give me the best papers you got. And so it's, you've got to be humble. You've got to know that you don't know everything, no matter how many years of schooling or experience you have.
How many blog posts you read or what have you. There's always an
entire library of stuff, and I'm still, I'm still stupid. So
yeah. Have a large bookcase. I guess another the pro tip from Celeste here. So you we've talked a bit about AI reliability and the importance of not just looking at the efficacy of your model, but also thinking through how long that your model is going to be effective, and I imagine determining thresholds and things of that nature. Let's talk a little bit. You just mentioned adversarial machine learning. I have no idea what that is. Talk to us a little bit about that. I don't. Yeah.
Wow. Well, adversarial machine learning really reared its ugly head in literature. about, I would say 5 years ago. Yeah, about 5 years ago. Think of it as model hacking. So it will, it's a great monitor to place in your ML ops to look for drift. So drift within your false positives or false negatives, because what an adversarial will do will, he won't know your features, he won't know your model. He'll come in and start pinging, and the response will come back, and it's like, oh, you got a response here. And so what he or she's doing is actually changing a column in supervised learning. He or she is changing the column of a feature from 0 to 1 or 1 to 0. And so
got it.
I have a black lab that just entered my office. He starts yelling at the FedEx guy. At any rate.
So if I were to try to describe it in my words, essentially, this is a bad actor who is essentially trying to create data drift and purposefully, like overloading the amount of inputs that you get into your model, and as you sort of retrain it, you will drift thanks to this one or two features or whatever it is that they're sort of overloading and skewing. Is that right?
Exactly. And what happens is that you'd think that they would have to know the model, but there's a great paper by Papadoe out there. I think it's. Sorry. Anyway, it's Papa something. I'm sorry. But if you just look up adversarial machine learning, his name will come up, and it specifically shows that you can ping with a regression model. And if your company is using a neural net, you can actually still impact that model, even though you don't know what the company's model is. And it's called transferability. And you're able to, this particular paper shows that there are a number of different there's a number of different models that you can use that have a particular penetration rate to other models. So it's a wonderful XY grid sheet that says, this is what we did. We used neural nets and it impacted, generalized regression, or we used generalized regression and it impacted neural nets this much. And in some cases, you'll find that it impacts it up to 98%. In some cases, it impacted only 30%. We did some analysis a couple of years ago where we looked at 700 features, and in a white box setting. So we knew the features, we knew the model. And we went in and we just changed 10 of those features from 0 to 1 or 1 to 0, 700. Right. And we literally changed the model to now detect malicious as benign. So, in other words, the file used to come in as malicious. Now, with a change of only 10 features out of 700, it is now benign. And so you've got to be really careful about measuring that drift, the false positives and false negatives for evasion and poisoning by bad actors. Yeah.
So, golly. It comes as, I guess, a little surprise to somebody like yourself in the cybersecurity industry that the bad actors are getting more and more sophisticated. I mean, essentially what I'm hearing you say is, I mean, not only are they potentially authoring and creating viruses and all sorts of different ways to sort of entrap folks like myself out there, but also they are going after the detection software itself. So the models that are used to detect their viruses, and they're trying to skew those models so that they can fly under the radar. That is terrifying.
Yeah,
model hacking.
I call it model hacking. Well, there is good news and kind of bad news. The good news is that when we started looking at it a couple of years ago, 2-3 years ago, there had not been a report at all of any AML attack within the companies. Mm-hmm. There is some literature that someone in, I think it was Australia, went in and went to a number of different companies, not McAfee, but they went to a number of different companies, and they were able to utilize AML techniques and hack in. And that was reported in the literature. The good part was that the researchers are ahead of the bad guys. That's a really good part, right? That's the first time that we've really been ahead of the bad guys. Instead of reactive, we're proactive. Unfortunately, there's always bad news because bad actors can read too. And so they're going to read all the literature out there. Yeah. And now you're seeing, there's been a couple of reports out there that it's starting to infiltrate. So it's just a matter of time.
Yeah. Well, I mean, the important thing.
Yeah.
Yeah. I mean, the important thing is that there's awareness, right, from the community. And there's people like yourself who are working to hopefully stay ahead of the game as best they can. But hey, sadly, without these bad actors, McAfee wouldn't be in existence. It wouldn't be needed, I suppose. Yeah. So I'm glad we went down that path because I really didn't know that much about it. But I can imagine. I mean, this is not just applicable to viruses and software. And sort of hackers and things of that nature. It's applicable to fraud and all sorts of different areas where heck, even getting your loan approved. If you really badly wanted to make sure that you cross that threshold, you could potentially, I imagine, if you're sophisticated enough, hack away at the model.
That's what's AML. And bias, of which you speak of, and anomalies and cyber checks, those are all monitors that you need to put in place, and eventually they'll give you a mathematical model decay, a visual model decay, and then you can mathematically calculate your MTDD.
Right. And then what you're doing with that MTDD, I assume, is like you have some, it helps you understand how often you need to retrain your model or how often you need to sort of, okay. So that's sort of and that makes a whole heck of a lot of sense. I mean, if you're trying to, if you have hundreds of models in production and, your team is only so large and you're trying to figure out what your team should be doing for the next 2-3 months, like knowing which models, you don't want all your models to mean time to decay to basically, all decay at the same time, right? You create this very lumpy sort of job for your team to do. So I imagine it helps spread the workload and
absolutely. Yeah. It impacts a lot of things, including resources. And if you can predict MTDD, you can plan for those resources. You can certainly meet and exceed your customer expectations. You assess and predict how long your model performs. It just goes on, ad nauseum. There are reasons why there's books and books on reliability, So I'm glad my two worlds kind of collided with reliability modeling and AI. So it brought me to this point here with you.
Yeah, that's fantastic. And now I'm getting completely off topic. But I think it's something that is important. I mean, I do talk about in the DSL podcasts about the importance of diversity in data science. And one of the statistics I've thrown out in prior podcasts before is I think 15 to 22% of data scientists are women. And I have to imagine out of that 15 to 22%, it's even fewer that are DSLs like yourself. Do you have any pearls of wisdom to the women out there who are aspiring DSLs or even aspiring data scientists? And maybe even advice for the men out there, the male leaders, in terms of building out a more diverse team.
Because maybe it's because I came from a very unique background. My undergraduate is microbiology and chemistry. My master's and my PhD are in biomedical engineering, but they really focused on neural networks and design of experiments. What I find interesting is that when we want a young, maybe an intern, we go to software, we go to the computer scientist. I would highly recommend going to other areas like biomedical engineering. I've never seen such a vast array of knowledge that look at a system from soup to nuts as biomedical engineers. And that's how they're trained. I always go back to what I was taught from my mentors, was learn your basics. And the first question I always ask anyone I hire is, do you have a good course, a year or two in statistics and regression analysis? Because if you don't, and there's my lab, my black lab. there comes FedEx. My little wireless doorbell there. If you don't have those, then you can't understand some of the other basics that go into model development. So I think it's critical for people, whether women or men, to come into industry with a solid background of data science or data science as well as statistics and coding. I find that I'm a little biased, but no pun intended, but I'm a big fan of design of experiments. And I have found that nobody in security knows anything about design of experiments. And it's really looking at the combinatorial and factorial impact of different contributors to your output and how you mathematically model that within a design space. And so I'm a big fan of that, but nobody is really in the security industry is aware of that. So if you've got something unique, like regression analysis, like a design of experiments, above and beyond the typical coding and capstone project of here's a model, here's my data, here's my output. If you have something more to add to that, that would be awesome. I like to find people who are good in something that have a passion specifically in an area. Like I love DOE, design of experiments and neural networks.
Clearly,
Can you tell? I am not going to hire somebody that is really good in neural networks and design of experiments. Why should I? I need to surround myself with people that know a whole lot more about control theory, for example. I mean, that's just... that's a good broad range.
Right. So I'm hearing you sort of recap. You make sure that you have a variety of sort of skills and expertise in your data science team. So it's not good to just have 10 data scientists whose sort of expertise is in neural nets or maybe just design experience. You want to have that sort of breadth amongst the team. And then the second thing I heard you say is that. I think you were saying this. It's just which is having a strong statistical background is very important to enter the world of data science. But you don't need to have a PhD in statistics if you have 1 or 2 years of stats. And there are a lot of different disciplines from folks coming out of college and even their master's degree where statistics is really important. And you need so you don't have to have your master's in statistics per se, but if it like yourself, where you had sort of a biomedical background where statistics was extremely important in being able to predict, I believe it was the chronic obstructive pulmonary disease.
COPD.
Yeah. I had to. In fairness, I had to Google it while you were talking, but so that can be applied to so that background, that statistical background, can be applied to other areas in the business world, and that helps as you build out that diverse team. So it's diversity in sort of background and diversity in expertise. That's I think great advice.
Yeah, you know what, Dave? I've been in 8 to 10. I've done data in 8 to 10 different markets in my career, and one bizarre thing that I've noted is that, and it's from printers, HVACs, windmills, you name it, right? Hardware, right. Computer chips, software, you name it, I've done it, right? And one thing I've noticed was that the data in cybersecurity, which have very few females, and the data in healthcare are very similar.
Yeah.
Very, very similar.
That's interesting.
Yeah. And they're both very complicated because you never know what you're going to get. Sorry.
Well, you're bucking the trend, and you have a long career to boot, and hopefully there will be many other data scientists who follow in your footsteps, male and female. And it's extremely impressive. So, I very much thank you. This has been fantastic. I mean, some things that we learned today about AI reliability and the importance of understanding the decay of your model, not just the efficacy, but how long your model is going to be effective out in the field, and being able, it helps with resourcing. It helps with knowing when to retrain and the model and so on. Very, very interesting stuff. If people are interested in reaching out to you and learning more, do you have a way in which social media or some way to get a hold of you?
Sure. I'm on Twitter at Celeste at Perkinji.
Okay.
Perkinji, and that's PURKINJE. They're actually fibers in the heart and fibers in the brain. So, I'm.
I was going to ask.
Yeah. Great. And I'm also on LinkedIn under Celeste Fralick.
Awesome. Well, Celeste,
it was a.
Yeah. It was a pleasure having you on the DSL podcast. Thank you so much for joining us. This has been great.
Thanks.